This right here is an electric vehicle, also known as an EV, as that's how the kids call it. This is a Tesla Model 3, nicknamed the Red Barron after its red paint coat. I've had fights with my dad about renaming this one. Electric vehicles have a lot of advantages over standard cars, and there's one that I really want to go over. And no, it's not that. This is a 5-seater family sedan and goes 0 to 100 in 3.3 seconds. That the car comes with a bunch of different games, including one where you actually control the game with the damn steering wheel. That it comes with a home charger, which means we can fill it up from 0 to a full tank for $5.60. $5.60. Or maybe the fact that it comes built in with Netflix, Twitch, and YouTube in the car. Perhaps because it's got an auto steer function, which means that I don't even need to touch the wheel for it to drive. It's staying between the white lines. Also, it's got a lovely sunroof. Or the fact that the car has a summons feature, which means I can control the car via a remote on my phone. The thing I find most interesting about this specific electric vehicle is none of those. It's in fact this. Now, it's not the wheel, it's what the wheel's attached to. Electric vehicles are attached directly towards an electric motor. Electric vehicle, electric motor, kind of clues in the name there, Sean. The fact that it's attached directly towards an electric motor means that it has access to a thing called regenerative braking. Now, this is something that only is applicable for electric vehicles, and to explain why, you need to understand the energy flow from the chemical side of vehicles to the rotational kinetic energy of the tires. I'll explain that in a second. Now, a standard car has 4 basic kind of processes it has to go through. You have chemical energy stored in a fuel tank, which is then pumped into the internal engine inside. It is then burnt and creates heat and pressure, turning the pistons and the crankshaft. The crankshaft turns the transmission, all the gears, the flywheels, la 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 la, which then connects to the wheels, and you're gonna get kinetic energy rolling. And we can kind of break it down into like different areas of transformation and kind of states of energy. You've got chemical energy and rotational energy, which is what you really want at the end. The problem here is the irreversible chemical reaction, which is combustion. If you ever try to light a piece of paper on fire and try to turn it back into paper, it's almost impossible. It takes a lot more energy to do. So once you burn it, it's gone. The problem really is that we're trying to get kinetic energy. And when you burn something, all you get is heat and pressure. So you're going to get a lot of waste heat, a lot of waste kind of pressure coming out through the exhaust, through the sounds and whatnot. And we've seen that ICE vehicles lose 60 to 70% of the energy that you pump into them chemically to the heat, to the sound, to the atmosphere. And when fuel is as expensive as it is today, you kind of want to have that quite low. It's like 60%. You really want that to be really, really tight. Additionally, too, you're going to have a few more losses because there's a lot of moving components, the transmission, the gearbox, the flywheels, all these components are trying to connect it, especially if it's like a rear-wheel drive. And finally, you've got some other outputs and losses, such as wind resistance on the car, if you're going up a hill maybe. You have the air conditioning on, you've got radio on, you've got some losses coming out. And so overall, you're only getting 12 to 30% of the chemical energy inside the car coming out as kinetic. Now, electric vehicles, very much the same. They want kinetic energy on the output, and they have a chemical storage, which we call a battery. Now, the battery kind of feeds DC electricity into a motor controller. The motor controller can invert that signal to AC if it's an AC motor, but generally speaking, transformations like this are really quite efficient. You're going from one type of electricity to another. Finally, the electricity will then go into the motor, which we've already discussed is connected directly to the wheel, which means there's not many moving parts for it to have losses on. We do have chemical energy on the far left, but a battery is reversible. It's a reversible chemical reaction. If you put in electricity, it charges up. If you connect it to a circuit, it charges down, it outputs. So as far as we're concerned, we don't really care what the chemical reaction inside the battery is. It, for us, is an electrical component. So you really only got 2 phases of matter for an electric vehicle and a smaller process. Additionally too, electric motors are really, really efficient. Again, the inverters are really efficient, 90 to 95%. Additionally too, the losses that you kind of get on an electric vehicle, like your wind losses, they remain the same, the kind of rolling resistance, they remain, but like the air conditioning and the radio, that's a lot smaller because it's already require electricity, which is what this battery is providing. So an electric motor is between 80 to 90% efficient when you look at the chemical energy stored in the battery and the actual kinetic energy of the wheels rolling, which is significantly higher than internal combustion engines. And this kind of leads into why regenerative braking works. Now that I've kind of explained how the energy transformation in an electric vehicle happens, I want to explain how the regenerative braking works inside an electric motor. Now in front of you here is a little DC motor that I got from J-Car. Now if I plug this into a wired circuit which provides electricity to the motor, it spins. Amazing, look at that. We've developed our own electric car, everybody. Now, if you get the exact same standard DC motor and plug that into a load, in this situation an LED light, and then spin the tire, you are now creating power that goes back in to the circuit. Effectively what it's saying is that a motor can also be a generator. A generator is just doing the opposite. Instead of taking electrical energy and turning it into kinetic, you're getting kinetic and turning it back into electrical energy. And by definition, the way it works, it's really, really efficient, which means that an electric vehicle can actually charge itself up by braking and then using regenerative braking to then power back the circuit. To me, that is absolutely insane, that a car can both use its own fuel and then generate some and put it back into the tank. Like, imagine driving up a hill and it uses 5 liters of fuel, then you come back down and it gives you 4 liters back. Like, wouldn't you want that in your car? I certainly would. And the point is, I'm not just talking like absolute porridge here, even though my name is Uncle Toby. We actually did this test. James and I did a drive around Wollongong to see how effective that regenerative braking is. So you can't really see it, but on the Tesla on the top here is a little bar, and that bar shows how the battery's being used. So currently, when it's green, it means energy is going from the wheels into the battery, meaning it's converting kinetic motion into electrical power, which is being captured by the batteries. When it, however, goes to the right, when it's black, it's saying it's using the battery or chemical energy to make kinetic energy by rolling the car. Right now we're going down a hill. You can see that because if you show the camera, going down the hill, it's green, which means it's producing power in its motors. Alright, so we're at the very top of Mount Ousley. We're at 55%, so we use another 3% to get here. Let's see what the percentage is at the very bottom of this hill. Yeah. And now we're at the very bottom of the hill, and the car's at 57%. Oh my god. How did that happen?
I'd say magic.
Nah, it's regenerative braking, but pretty much, yes, magic. It's magic. And now I talk about electric vehicles being such a fun new technology, it's going to become the mainstay going forward. BMW, GM, General Motors, pretty much every single car manufacturer has agreed to be electric vehicle or plug-in hybrids by 2030. By 2050, it's going to become the mainstay. So the sooner we understand the technology, the better. So I do encourage you to learn more about electric vehicles because the price benefits alone kind of justify them being available. So if you liked the video today, please consider liking and subscribing to the Engineering Dads. If you do have any questions about the Tesla, I'm very happy to answer them. Please just place them in the comment section down below, and I'll hopefully see you in the next one. And to finish this video, here's a video of James shitting himself while we drive around Wollongong's windy roads. Ready? Oh.
Oh shit, dude. That can't be safe. Oh my god.
Ready?
Oh my god, dude. Oh my god. It's like a roller coaster almost.
Yeah, right?
Except like it's more realistic than it's not safe. Oh my god. 100 or 90.
Yeah, or the accelerator back to mine.
Oh, yeah, 60.